Okay, so again, good morning, Kevin Leach. I want to do a little quick introduction and recognize some of the emails, so maybe some of you guys have talked with me or been in a class that I've given or whatever, but just a little background. So 20 plus years using PTC, Pro Engineer, Creo, Wildfire, whatever you want to call it. It's the CAD tool for PTC. I kind of come out of the sheet metal industry, so it's kind of interesting. They asked me to run this little webinar for a sheet metal conversion tool, which is a very narrow bit of the sheet metal tool, but ultimately it's an important part of the tool. So I come out of sheet metal. This was the very first part of the software that I learned, and I've been using it ever since. And so I've got some pretty good little experience that I can, kind of talk back to. So the sheet metal conversion tool, there are a couple of reasons that you have to and want to use the sheet metal conversion tool, as well as a couple different ways of using the tool. We'll walk through a couple examples of each one. So first is there, when you first go into converting a solid body or a solid, Creo part or whatever you want to call it, there are three options, right? So driving surface, shell, and empty body. We'll talk through all three of these and some of the little differences between them and when one makes sense and when one doesn't make sense and what I've used it for. So I'll try to add a little bit to this. We've got an example of a driving surface. So this one would be more of a driving surface where it is like a piece of bar stock and you want to go in and bend it. They've made a bunch of option changes to this over the years. Originally, I used this for when I was doing, like I got a CAD model that was a bar stock, and I wanted to add some bends or do some work to it. So that's been around for a while, and like I said, they've had some options where you can exclude surfaces and deal with rounds and some other stuff. We'll walk through that. Example of a shell. So the second option there is the shell, and that's basically I'll do an example of a door type piece of sheet metal and how you would convert that from a solid and why you would even make it a solid first, right? So that's the other reason. Why would you purposely make something solid and then convert it to sheet metal as opposed to starting in sheet metal? So there's some examples of that. And then the last one is this empty body, which is fairly new, and these screenshots are from like Creo 9. So some of this, depending on how far you go back, might not have the same amount of options, but I'm in Creo 9, and if you have options or questions afterwards about your particular version, just let me know and I'll send you some screenshots specific for that version. Creo 10 is actually out and available right now at PTC, so although we still probably aren't recommending to our customers right now to go to Creo 10, Creo 9, absolutely. Creo 10 probably in a couple more months. I like to see a couple little build codes go, and then we'll kind of suggest going to 10. I'm using 10 for my own stuff on the outside. I like it, but this demo we're going to do today is all about Creo 9. All right, so let's take a look. I've got my background colored black, so hopefully that's not going to bother anybody. It's just a background color. I can, very easily go and change that option to make it default, but I kind of like the black background. It's easier to see the context. And I'm not connected to Windchill right now, but I could be, not a big deal. I'm going to sheet metal folder, set my working directory, and we're going to work through a couple of these examples, right? So let me start with the empty one. So let's do the first option there, which is empty. Basically is, hey, I started a solid part. I went in and then realized, oh, I got the part started. I already got my parameters filled in, and maybe I need to, I should have done this in sheet metal. So if you go operations, convert to sheet metal, you'll see the empty body shows up right away, and that's all you have to do to convert. Now I'm in sheet metal. So, would I normally do that? No, normally I would start with my sheet metal start part and then start working from there. But that's one of the options for conversion. So I wanted to show that. Another option would be the driving surface one. So let's take a look at one of them options. So basically we have a piece of bar stock, and maybe I want to add some more bends to this or do some other work, and I want to convert it into sheet metal. And in the past, this would give us a problem, right? This is a non-default thickness issue where this is definitely thicker than the thickness of the part. And obviously in sheet metal, you can only have one thickness, right? So in the past, we would have just went and found those and suppressed them. And you could still do that if you wanted to and convert it there. But we can also use the options now to kind of do this. So what we're going to do is operations convert to sheet metal. And we're going to pick driving surface. And I've got driving surface as that top one. And then I'm going to say include surfaces. And again, should have used my control button there. Use my control button to collect the surfaces that I want to add. And then I can exclude. So now I got some options. If I grab any of these surfaces, it will try to hollow that chunk of material, right? So now it's, again, it's got to be a constant thickness. It's using the original thickness of the part, and it hollowed that out for me. If I don't want to use those, right, I can uncheck them, and I could say, hey, instead of doing that, let's exclude them from dealing with it. And I could go to options, and now I can deal with these rounds on the corner, right? So do I want to recreate the rounds or to remove the rounds and make it square? Do I want to ignore them, right? So we have a couple options right there. Say, okay, it gives us a little warning, but it'll go in no problem, right? And there's our sheet metal part. Now I've ignored that. We'll go back and do it the other way in a second, but just to kind of get us in here and get started. Because it's all simple, all constant thickness, we can easily get a flat layout of that based on our K and our Y factor. We can add to this if we want. So I can go in and say, hey, I want to add a flange to this, or a flat wall, and I can continue, right? So I could say, hey, not only do I want that, I want to add another flat wall on the backside, or I want to add a flange along the bottom, and I can use my flange tool, right? And get a flush and a hem bend and get the flat layout, right? So that's just a non-normal, change there. And you could go in and you could add a flange to this. Let's go into shape here. Hang on here, I'll get it. There we go. I can do some crazy stuff in there with a flange cut like this, or add or a duck, or just got to get the dimensions right to get it to work. I can go all the way around that. Let's go back to the one that actually worked. See, right? Oop. So some crazy shapes on that way. I could have removed this hole completely, right? So one of the things in flexible modeling is you can go in and say, hey, you know what? I don't even want that hole there at all. And then I could go into there and say, I want to create a sketched form, right? Which is just maybe some circular shape. Add some taper. That's too much, but maybe like that. Add my rounds. I can put a hole through the center of that. And say, okay, right? So we can get a form punch in there like that if we wanted to add some, a lot of options we could deal with. So that was one way to kind of deal with that. The other way would be to leave that chunk in there in the first place. So let's do it one more time. So this guy. So let's go convert that again to sheet metal. Driving surface, select the first one. Right? Control, grab them all. And this time I'm going to grab a round set, right? And it's going to get me into sheet metal as well. And I could go in and do a flat. Maybe I got to use the flange now. Flange. It's a little weird. Make sure I can't get to my flat now because it's going to have that as a non-deformed thickness. So in this case, if I wanted to get the flat, I would have to come in here and suppress them, like I said in the other one. So I could go and suppress that. Redefine that, get rid of the individual surfaces, which of course now I can't do because I can't see them. So let's do this. Just delete it. Do it again. So I ran myself into a little bit of a problem there where I suppressed it, but once I suppressed it, it was part of the selection. Let's make sure we get rid of the corners. That's probably what I was having problems with when I was trying to add the flat wall there, was I had the rounded corners and I didn't take the ability to get them out. But there's a flat wall. Here's the flange, right? So I can have a flush. Sorry about that. So there's that same part. And again, I just suppressed the two non-defaults to kind of get in here. And I can always go back and add that either with a punch or a form of some other kind, a die form or a punch form. But that's bringing that in, again, using the driving surface, right? So the driving surface basically just is click one side of that, and then it'll use that to drive the offset, right? And then you're into sheet metal, so you can do all your sheet metal stuff, right? Flat walls, flange walls, merge walls, unbends, right? You could add an unbend. We could add a cut across the bend. I should have made that a sheet metal cut, not a extruded cut. There we go. Clicking sketch, normal to surface. Through all. Try to get the thin cut. I'm not sure what I was doing there, but basically you can add your cut, do a bend back, right? So a lot of the regular sheet metal tools that you would normally be using once you get in with that driving surface. And I've done this where I've got a model from somebody and it was a piece of plate steel and we wanted to add some bends and find out what the overall bend were going to be or the overall length was going to be, right? Not a big deal. So that's another reason to convert and another option. And then maybe you want, again, to convert. Let's do this. It's already been converted. So let's go back out here. Let's use this one, which hasn't been converted. So we're going to convert this into sheet metal, and then we're going to use the conversion sheet metal tool inside sheet metal, right? So that's another step to this. So convert to sheet metal. This one's going to be the shell. I'm going to exclude certain surfaces, right? And that's going to get me into sheet metal, but that's still, although I'm in sheet metal, I still can't make a flat of that because it doesn't know what to do with these bends, right? So we have to then use the conversion tool inside here. And what I like about the conversion tools, we could actually add rips and do some rips and stuff and add rounds, but the conversion tool kind of does some work for us automatically. So when I go in and say edge rip, and I want to do one more thing before I do this, I'm going to add a datum point just to make my life a little bit easier. So I'm going to datum point, and I'm going to go off of this reference and 1.5 off of there and say, okay. Let me just look at the thickness here real quick. Let's make this 1, Control G, and then change my point to 1 off, because I'm gonna use that to drive my cut inside the inside the conversion tool. Right. So conversion, edge rip, pick the edges you want ripped. So I want that ripped. And you can see it tries to add the rounds that it needs. I'm also going to add that as a rip, but I'm not going to go the whole length. I'm actually going to drag this thing back, use my shift button, and grab the point. So I'm using the point to drive the edge rip, and then control rip that one as well. Everything else kind of rounds, right? Now I have some ability to control some of that. I can go in here and say, hey, I want a gap in between these and give it some gap, right? So I could say, hey, 2 times the thickness, or you know your numbers, so we know it was 1 was the thick. I can go 1.5, right? It's going to give us the rip there. We can go 0.5, right? We have a couple. We have blind, we have overlap, right? But gap is fine, 0.5 is fine. Now that's still not enough information because it still needs to be connected here somehow. And I'm going to do this 2 ways. One is I'm going to use a rip connect and do it in this one feature. And then I'm also going to do it again, and I'm going to leave the rip connect out and do something a little bit different. But let's just keep it all within this one feature, which is nice about the conversion tool, is we can put a bunch of these features all in one, right? So I'm going to do a rip connect. I'm going to grab that end, control and grab that end, and you'll see it makes that nice straight rip, right? And again, I can add a gap. So maybe I want a little bit of a gap here to give them some room to put this together. And then the last thing I might want to do while I'm in here is I can also control the corner relief. So right now it's a V notch, and I might want to go to obround. So I'm a big fan of obround, whether you're doing sheet metal punching or you're doing water jet. Obrounds create a nice smooth transition from the cut out, and you don't get that sharp edge, right? With a V notch, you get a sharp edge and you'll end up cracking that in the corner. So I kind of like this obround myself. And again, we can play around with that a little bit, make it bigger, smaller, you know, whatever I want to do. I can type in a number if it makes sense, 1.5. I can move this in and out by, instead of on origin, up to bend, right? Or a blind dimension where I can control the dimension, how far I want to go with that. Again, I can go 2. You can see how that goes into the model. I can play around with the rotation of that if I wanted to a point. You know, it doesn't make a lot of sense for me, but you kind of get the idea there. Hopefully I didn't stick that at 360. Uncheck it. But it could be an obround, it could be circular, it could be square. Like, it doesn't make sense to me to be square just because that's a sharp edge and that's going to end up cracking right in the corner. So I'm either going to be an obround or a circle, one of the two. But I can control that, again, all in that one feature. So when we're done, and we're done with the conversion tool, the edge bends we already got, so that's all good. Done, right? Now, that's one feature, and if I hit my preview, I've actually got a flat layout. And although I don't mirror things a lot, you can go in and you can, where's the mirror feature in here? It's on the transform, so I can mirror that whole thing. And maybe I can't. I just had the wrong thing selected there. So you can mirror it to there. We could take the whole thing again and mirror it to the bottom. Now, this is probably not the way I would build this, but this is just to show you some of the strength that it has, including the layout of that flat box, right? Problem is, for me, for not doing that is because probably I don't have a die that's going to fit down inside of that and get me that gooseneck because of the small cut here. That'd be a pain to do. So when I've built boxes in the past, in the real world, what we've done is made wraps and then remove, put the two sides in and either spot weld or weld. But that's a pretty common kind of setup. So I'm actually going to do a box the way I kind of like to do it in a second here. But I also wanted to show you a couple different things. So let me delete this. Let's just delete the two mirrors and redo the conversion tool, right? So I told you I wanted to do something different with this rip connect. So let's see if we can get rid of the rip connect. Say okay, right? Nope. So I'm gonna have to do that connection all over again. Let's go delete. It's easier just to do it from the beginning. Reconversion, edge rip, same edges here, here. I bring that back to the point in there, right? I might still do the same with my corner. Make that a odd round, 1.5. All right, good enough for now. What is going on here? Corner leaf. It's not what I want. Hang on. Do this one more time. Conversion, edge rip. All right. I just want to leave it like that because what I want to do is I want to control this rip a little bit different. I could do the connect rip and do the corner, do all that stuff in there, but what I wanted to do was show you that you can also come out here and do a sketch rip. What I like about the sketch rip, which is a little bit different, is not only can I make that rip, right? I could just draw a line from there to there, and that will absolutely do the same thing. Like if I leave that, that'll rip that corner. But what I want to do is I want to put in a target, right? So some way for the guys to know as they're building this that they're fitting things together. So I'm going to go in and put a little keyed access to this, and I can add my rounds here too. But what I'm going to do with that is a little bit different, right? Because there's my key, and we can look at our connections. I want to give myself a little bit of relief in there, so I'm going to unbend everything. And then I'm just going to go in and add some rounds. So engineering rounds, grab one, grab the other. And I might do the same to these on the outside here, right? And maybe actually make that a little bit bigger, 0.5. And then do a bend back. All right, so now we get a little bit of extra room in there so they can bring it up, key it, weld it solid. And again, I can mirror that around if I wanted to. So we can go select this and then do mirror. Select it again, do mirror, right? And then when we do our unbend or our flat pattern, we're going to get all of our keys, all of our cuts, all of our rounds, right? So not bad. Like I said, I wouldn't do this. I would probably do it as a wrap, but you kind of get, even in a wrap, you can do the same techniques. So the last one I want to show is the shell tool altogether, kind of in one of my ways of doing it, right? So one of the things I like is why design it in a solid first, right? So that little box that we made, I might want to have a door instead. Like, so maybe I'm building cabinet doors. So I've got an extrude that's a simple 15 by 22 round, and I might want to build a secondary extrude off of this with the loop offset. So grab one, grab the surface, give it an offset. 1.5 is fine, and give it maybe a 1-inch thick. And now, in order to convert that to sheet metal, and again, it's kind of going to be the same thing. We're going to go in that conversion tool. We're going to add edge rips and rip connect, and whether I do surface rips and all of that. But to get there, we're going to go operations, convert to sheet metal. We're not going to use driving surface. We're going to shell. We're going to remove the bottom. We're going to give it our thickness. So 119 maybe cold roll, right? And then I can go in and do my conversion tool and say I want to do edge rips. And I'm just grabbing all the edges that make sense. It's putting on the rounds automatically for me, right? And again, if I left right now, that's obviously not going to unbend because I got to do some kind of rip connect, right? So maybe we want a small gap. So let's go 2 times the thickness, so a little bit bigger gap. And let's make that, I don't want, that's quite a big gap. So let's go thickness. Good enough. Done, right? That's step one. Step two would then be to do the rip connect. And it kind of, as I bring that tool over, you'll see it's kind of grabbing. What I want is to grab from there, and then it goes into this connect mode. I'm using my control button to grab the other side of that. Then let go of the control button and go to grab another one, control. Grab another one, control. Grab another one, control, right? So now I got all my rip connects. Maybe go into my corner reliefs. Oops. No, don't leave. Corner reliefs. Set up to be automatic, right? So manually I could go pick each one if I wanted to. And you can see with the annotation turned on, it's telling me what it is. Right now they're all V-notch, but I told you I like browns. And same control that we had earlier, and say okay. And there is our flat. And then if I modified the original shape, which is the reason why I did this in the first place, I like it because it will automatically update everything. And I can have one door shape as a template and then use it over and over and over and over, right? Like that's the goal, is to, I got some shape that I'm doing 1,000 times. I want a very specific layout of the flat. This is the way this is a reason why I do a solid part and convert it to sheet metal and then using the conversion tool to get what I want. And I could key this just like I did before. I'd just go into the conversion and not do my rip connects. Let me just take one of these out. And then I could have done them all, right? Remove them all. And then I'm just going to go in and do a surface rip, a sketch rip, not a surface rip. And then draw that shape that I did like the last one, and then put in the key, slanted rectangle. Delete it. I could do that for all 4 corners and have a key, put my rounds on, add some little bit of relief in there so that they can form it all up. Take a pair of vice grips and some sheet metal, kind of clamp them together and weld everything solid, right? That tells you, one, that you're punching and you're water jetting, however you're cutting the flat pattern, and your bends are all coming together using the right bend deductions, and you're everything worked out perfectly mathematically. And when they weld it up, you get a nice solid, connection. So those are the very traditional reasons why you would use the 2 tools that convert from solid parts to sheet metal, and then the conversion tool, right? Without the conversion tool, let's say we did this, you can, I'm actually gonna, let me go back here a little bit more. Delete, delete, delete. Let's convert just to one panel here. Operations, convert to sheet metal, shell. I'm just simplifying it to make it a little bit easier this time. Right, what I can do, is I can go in and add run, let's see. Edge bends. So this is another way without using the conversion tool, kind of a different way of looking at trying to convert something from a shape that's not able to go flat once you get in here. And then you can come in and add your edge bends and then go in and do surface rips and just rip out the surfaces that are keeping you from getting a flat pattern. So that's just another way of doing the same exact at the end results. Right? And I get my flat pattern that way. Right? So that was another way to do that, just using the rip command itself. So even though you didn't do the conversion, you can still do all of the other regular rip tools. Most of the time I start in the conversion and then work my way out because I get all of those tools in kind of one feature. It's kind of nice, right? And then the last little bit of this that I wanted to show was there are something new that came about like Creo 7 or so, but basically it allows me to bring a step model in. So let's take this guy and drag him and drop him. I'm going to use my regular template, right? So I get in and I've got a Creo template. I've got my model, but we know it's an imported model, right? There's nothing that's sheet metal about this. I can't flatten this per se, but what I can do is I can convert this into sheet metal, just like a regular part. I can use the driving surface, say, okay, now I'm in sheet metal. And I can use my flexible modeling tool in sheet metal to do all kinds of things, right? So we can go in and say, I want to edit the bend relief. Grab it's not what I wanted. I want a corner relief. Corner relief. Grab it. And right now it's a V notch, and I can make that an eyebrow. And again, this is an imported part. This is something we weren't able to do not too long ago, where now I can go in and specifically take an imported part from some other SolidWorks or Inventor or some other step file output, convert it into sheet metal and get the corners that I want. Or maybe I even want to move things, right? So I can go in here and say I want to move that whole corner here. Right? I can drag that wall out. And keep tangency. And maybe not in this case. Might have got myself a little bit of jam there. Let me try something else here. Let's try. No, all right. I wasn't really planning on mucking around too much with the flexible modeling there, but there are a bunch of things, and I can always, maybe it was that one. There we go. That's what I was looking to do. So I just had the wrong tool there. In flexible modeling, you have the ability to pull walls. I went a little too far. I failed one of my move tools here, but that's kind of what it's doing. Right? So pull wall is the one I was looking for. And it'll take the side seams with it. So I can change some of the length of that. I can change some of the height. And of course, it's still in sheet metal, so I could add, maybe I need to add a flat wall to it. Grab the other edge. And maybe a little tiny offset wall to it. And again, remembering that this was a imported part that I'm working with, right? That's kind of the whole idea of that thought, is that when you bring an imported part in, if it's a constant thickness part, you can convert it into sheet metal and do some of those sheet metal tools with it, which is pretty outstanding, I think. So flexible modeling has come a long way over the last couple of years. Depending on what version of Creo, if you go back to like Creo 6, maybe this might not be available. You'll have to take a look. But Creo 9, Creo 10 obviously can do it, no problem. And of course, you can unbend once you've got that. You can do a rebend. You can do a cut across something. You can do a ton of work with it. All right, I think that was pretty much. Not sure what that one is. It's just, again, just another imported part. You could, driving surface and kind of work to it. Convert to sheet metal. You can still shell it out. So if it came in as a solid chunk, you can still, again, imported parts. You can then go into your conversion tool, add your rips. Adjust what you want there, and then it'll add the bends and you're done, right? So even imported parts you can still deal with inside of sheet metal. I think that's a pretty impressive part of the tool. It's come a long way. A lot of this, some of this I've been able to do for a while, but this converting a imported part is fairly new. Okay, I kind of went a little quick. If anybody got any questions they want to add in there or ask, I'll try to do it on the fly. I don't see any questions. I thank you for your time. I'll give you back 15 or 20 minutes. That's kind of what we had to cover today. Thanks for coming. And again, if you have any, here's my email. If you have any questions, reach out. If there's something specific that you wanted and I didn't do, let me know. I'll take some JPEGs and put it together in a step 1 through 5. Good luck and happy sheet metal. Sheet metal, like I said, is one of my favorite parts of the whole Creo package. So feel free. Thank you.